Hello. Hello, Sayali.
Yes, sir.
So, when we are supposed to start?
So in a minute.
Okay, so are we expecting more people?
Yes, sir.
Okay, please let me know when we have to start.
Yes, sir. We'll start in the next 5 minutes, next 2-3 minutes more.
Okay.
Good morning, everyone. We are starting with the session. Well, I hope you are doing great. Well, before starting, please let me know if I'm audible to you and my screen is visible. Just drop yes in the chat box. Okay, thanks, Dinesh. Well, I'm Sally Thavre, your host for today's webinar, and it's a pleasure to welcome you all in this webinar, Building Application with Search in Azure CosmosDB for NoSQL. Well, today's goal is to provide you with actionable knowledge, and we definitely encourage you to participate by asking questions and giving answer and engaging with us throughout the session. Well, today's webinar is organized by ETC community and sponsored by Synergetics and Microsoft. Well, this community is open to all who are eager and interested to learn and explore emerging technologies. You just need to follow our groups on Meetup. Now, I'd like to introduce you to the Synergetics that is sponsored of this webinar. So, Synergetics is a learning and cloud-based company who helps organization professionals to enhance their technical capabilities and adapt to evolving digital landscape. So, these are some master solutions that Synergetics offer, that is persona-based onboarding, onboarding add-on, certification, certification add-on, reskilling, emerging technology training, certification hackathon, cloud adoption, latest technology training, sales, pre-sales training, practice playbook, and architecting. This will be your scaling journey. First, you have to start from the fundamentals, then advanced role based, then you can apply for expert. Well, this is a emerging technology community. Everyone can join this. Pune people can join this community. This one is for Gujarat people. This one is for Nagpur people.
Saili, I think you are not sharing the screen.
So I am sharing the screen. Is it not visible?
No.
So is it right now?
Yes. Yes.
Okay, so I'll just reshare the community. So these are our communities. This is the emerging technology community that we run on Meetup. Everyone can join this one. Those who live in Pune can join this community to keep themselves updated about the Pune meetups. This one is for Gujaratkar, and Nagpur people can join this one community. Well, this is the agenda of today's webinar. And today's speaker for this training is Mr. Sonu Satyagas. So he is a Microsoft certified trainer and currently working with Synergetics as a practice head. Well, there's a small code of conduct which everyone need to follow. So please note that you cannot take a screenshot of this presentation or presentation shared by a speaker. Also, please do not screen record. Well, don't forget to follow us on our social media to keep yourself updated on our upcoming workshops, webinar, and meetups. Well, thank you everyone for your attention to my words. If you are facing any technical issues, what you do is put that in chat box, and I'm happy to help you there. Well, Mr. Sonu, you can continue from here. Thank you, everyone.
Okay. Thank you. So, good morning, everyone. I hope I am audible to all of you. Please acknowledge before I start. Am I audible to all of you? Okay. Okay, fine. I hope the screen is visible to all of you. So this is the topic for today's webinar. Myself, Sonu, and I'm the Assistant Manager Technology at Synergetics. So I'm into training from last 15 plus years, mostly delivering sessions on open source .NET, DevOps, as well as AI. So I'm a Microsoft certified trainer, delivering sessions for Microsoft on various Microsoft certifications. Also, I'm an AWS authorized instructor, delivering sessions on AWS content as well. So this session is part of an emerging technology training where we have taken a particular topic that is vector database and vector search using the Azure CosmosDB for NoSQL. So this is the agenda of today's session. To understand what is the use of vector database and how to use it, and how we can specifically use the Azure Cosmos DB for NoSQL as a vector database, we need to understand the fundamentals of generative AI and why we have to use a database in our AI solution. So we need to understand what is prompt engineering, what is the use of context data, how we can provide the context data with the help of vector databases, how we can create the embeddings and store that embeddings into the vector database. So we will be discussing these points in today's session. So I'll be starting with the fundamentals of generative AI. So I'll quickly finish that points and then we'll move into the actual vector embeddings and vector databases. So to start with the generative AI, the artificial intelligence is not a new term which is which was there in the industry from last 50 plus years. But the emergence of AI technologies became popular, or the emergence of AI technologies came in 1990s with machine learning models. So machine learning models are artificial intelligence models that can be used for making predictions or taking decisions based on the data. So in that case, typically what we do, we use a kind of algorithm which performs a lot of mathematical or statistical calculations to predict the result. So for that, we have to train that algorithm or train that model with some data. So we call it as training data. So we train the model with a large set of data, and the model is understanding the patterns and relationships between the data points. And then when the user provides an input data without the output, the model is able to apply its learned knowledge to predict the result. That is what simple machine learning does. So simple machine learning performs some mathematical or statistical calculations inside to do the predictions. But when we deal with the complex data like audio, video, images, and so on, so simple machine learning models were not sufficient to extract insights from these unstructured or unstructured data. For example, if I have to identify the language from the audio signal, or if I have to detect the objects from images, or if I have to identify the scenes from a video frame, it will be very difficult to use a machine learning model for that kind of scenarios. That's why there was a new model introduced or new type of AI model introduced, which is called the deep learning models. So deep learning models uses artificial neural networks, which simulates our human brain. So how our human brain is working. The similar way, the deep learning models also uses artificial neurons to analyze the given data and get insights from that. So, as a human, when we look into a picture, we are identifying what are the different faces in that picture, or what are the different objects in that picture, or what are the different colors used in that picture. Or if you listen a voice, an audio, you can understand what language it is. Okay, whether it is a male or female voice. Okay, so that understanding how the brain is doing, how the human brain is doing with the help of neurons. Similarly, in deep learning models, there are artificial neurons, which is written in high-end languages, which is also kind of algorithms and data. So, which can also process the images, video, and audio same like our human brain is processing, and it can generate the results out of it. But even though if we are using deep learning for analyzing the highly complicated data like audio, video, and images, or even text, it is not going to generate anything new for us. If the model has to work, we have to provide the data, and the model is just analyzing it and giving you the response. For example, if I give a picture, an image as an input to a model, the model can tell you, okay, how many human faces identified in that, what is their position, or what is their human face expressions or attributes, or what are the different objects identified inside the image. But it is not going to generate anything new. It just analyzes the given data and generates the results out of that. But later, when we started working with the modern applications, we started using various types of data, but because of lot of restrictions in restrictions and regulations, we were not able to use the user data or private data. So we needs to go and generate some new data. For example, as a developer, suppose if you have to test your application with some data. For testing the data, maybe you are creating an application that handles the stock informations. But as an organization, they don't want to use their stocks information data for testing. Then then how will test the data, or how will test the application? So to test the application, we need the data. But unfortunately, the actual data is not allowed to share for testing. So then we have to generate some new set of data, or we have to simulate and generate a new set of data, right? Or suppose if we have to use an image inside our application or inside our website, we cannot simply go to internet and download an image and use, because a lot of images now have copyright issues. So if you use that images, then you are actually violating the copyright rules. Then what is the solution? You have to generate a new image and use it. Or else, if you are planning to create an animation or video, you cannot use an existing video, or you don't want to spend time in shooting that videos or paying for actors and doing that. So instead of that, you can generate some video. But how? For generating something new which is not existing, we need to have a model which is capable for that. Such models are called generative AI models, which can create something new which is not existing. For that, what as a user, you are supposed to provide the instruction. So as a user, you can say, okay, I want to create this type of data, or I want to create the data with this particular specifications. Then the generative AI model generates this data for you. So simply generative AI models, which are recently introduced AI models, can generate some new set of informations. Either it analyzes the given data and interpret and generates a new information out of that. For example, we can provide some input information. The model can analyze that data and then create something new, either similar to that or something different. Okay, so anyway, that generative AI models it always generate something new, either with the user data or without user data. Sometimes we provide the instruction plus data, or it will, or the user will be giving only the instruction. Suppose I can tell the model, okay, draw an image of a tiger. It is just a input instruction. Okay. Or else we can say, okay, draw an image of a tiger like this. And then we are uploading an image. So we are providing an image as an input and then giving an instruction also create an image similar to this, which means it uses the given image as a reference and then creates something new like that. Right. So that means generative AI models creates some new informations based on the instructions and the reference data given by the user. So there are different AI, generative AI applications and services. Currently, I think all of you will be using ChatGPT or Copilots or the video editing softwares or video generation softwares, okay, or image generation softwares, which are currently using the generative AI models behind the scene. So if you are a developer, you must be using the GitHub Copilot or Code Whisperer or some other developer productivity tools that can generate the code for the developer. Means as a developer, you don't need to write the code. You can just tell the model, okay, I want to generate the code for so and so purpose. For example, if I have to implement the binary sorting, you can say, write a Python code to perform binary sorting. So the AI model will generate the function for you. Okay, so that means nowadays we are using this generative AI models in various domains. But as a user, when you consume this generative AI models for various purposes, the important thing is the instruction given by the user because the model is not proactively doing anything. If the model has to generate something, you have to provide an instruction. So that instruction is called a prompt. So if you are using a prompt which is not clear or not specific to the information, then the model is not able to generate the data properly because the model will get confused what to generate. So whenever you write the prompt, you have to ensure that you are conveying the actual information to the model so that the model is able to understand it clearly and generate the data. So we will be using prompt for various purposes. Suppose if you have to do text classifications or uh, sentiment analysis, we can use generative AI models. For example, if we have a website like a Book My Show or Flipkart, so where the customers will be giving the feedback whether this product is good or whether this movie is good or not. So based on the user feedback, we have to analyze the sentiment. So whether it is a positive feedback or a negative feedback, because based on the feedback only we are increasing or decreasing the rating of that product or service, right? So to analyze the sentiment, we can use generative AI models. If we have to generate some new content, we can use generative AI model. For example, even small kids, means those who are studying in school, they are also started using this generative AI models now. Because whenever they get an assignment from the school, okay, tomorrow you have to write a story. So what the kid will do, they will come back, take papa's or mama's mobile, go to ChatGPT and then ask, okay, write a story about a monkey. So they will get a story. So the student is not doing anything. He is just coming and asking the ChatGPT or any other AI model to generate a story, poems, blogs, and so on. So if you are a content creator who is writing blogs or anything, you can now easily create the blogs and articles by using this generative AI. That means you can tell the AI model, okay, I want to write a blog on this particular topic, include so and so points inside the blog. So it will create the complete blog for you. Similarly, for language translations, you can use generative AI models. So you can tell the model, okay, I'm giving you the French language or Spanish language or Arabic language, you have to convert that into English. So then you provide the French or Spanish or Arabic text, it will be converted into English by the generative AI model. Similarly, for text summarizations, like suppose you have to read about some celebrities or some incidents or some movies or something in the Wikipedia. So, Wikipedia is a very large uh, uh, database, and you can see the information about anything in Wikipedia. But you don't have time to go and read each and every line of code. So, what you can say, okay, this is my content, just to summarize it and tell me what is the main points in just a 5 sentences. So you can tell generative AI model to summarize the Wikipedia content and summarize that in just a 5 or 10 sentences. So instead of reading that 100 sentences, you can just read just 1 or 2 paragraph. That's it. So that is summarization you can do. Continuation means like as a developer, whenever you write code, you are supposed to write the beginning letter or beginning word of your function or a class or some other entity. It will automatically complete the code. Okay, so that means it can complete the user prompt. For example, you are planning to write a story. So you write, once upon a time, there was a king, and rest of the things it will automatically fill. So it understood from the input. What is the input you give? The beginning sentence, like once upon a time, there was a king. So it understands that you are planning to write a story about a king. So it writes the remaining things. Question answering. So for like a Google, any if you have any doubt, you just go to the Google and ask, okay, so what is this? What is the answer of this? So Google is able to give you the answer, but Google is giving the answer in the form of search pages, right? Or search results. And you can go inside that page and find the answer. But in generative AI applications, you can ask the model the question, what question you want to ask. For example, how far is moon from Earth? So you want to know the distance from Earth to moon. So you ask this question, then the model is able to tell you the distance. Okay. So these are some use cases. But nowadays, one of the very commonly used use case is chat agents. Chat agents means suppose in a service provider company like uh, airlines or the IRCTC kind of websites, you can see there will be a chat agent. If you have any queries about their products or services, you can simply go and ask the chat agent. And the chat agent is able to give you an answer for that. Right. So some of the chat agents will be providing the static answers, but those chat agents which are using the generative AI models, they can generate the answers dynamically and provide to you, the customer. But the question, so this is why I have highlighted this chat in this list of use cases, because here we are going to use our vector data. But how? So consider that you are planning to create a chat agent for your organization. Suppose your organization is providing products and services to its customers. Maybe uh, your organization is providing health insurance informations to its customers. So whenever a customer wants to take a health insurance, they can come to the website and find the number of the customer care agent and he will call. So when the customer calls the customer care agent, he will explain what are the different products and services they have. For example, if I am a customer care agent and I am working for a company who provides insurance policies and so on. So whenever the customer calls the customer care, as a customer care agent, I will pick up the phone and start explaining the explaining about the life insurance policies or the health insurance policies to the customer. For example, if the customer is asking, okay, so your company is, suppose my company name is ABC, so ABC Insurance Company. So when the customer calls the ABC Insurance Company and ask, okay, as an insurance company, what are the different types of insurances you have? So we have a product manual, right? Or we have a product uh, list or services list. So by looking that list, I will answer as a customer care agent. I will say, okay, we have insurance policies for accidental death, or we have insurance policies for child, or we have pensions, different pension schemes, including the insurance schemes inside that. So we will be explaining the different insurance policies we have, or the pension schemes we have, right? So as a human being, I am able to go and read the document, the manual, the product manual or service manual, and I can answer that question. But now the company decides, okay, why we have to pay salary to this customer care agent? I don't want to uh, use a customer care agent for that. Instead, the customer can directly log into the website, and we will be providing a chat agent, a chatbot. So they can ask anything to the chatbot, and the chatbot is able to answer the question. So if the customer is asking, okay, what are the different types of policies you have? So the chatbot is supposed to answer that. Okay. So that is what my intention. But understand, if we are using generative AI models for answering these questions, there is a challenge because generative AI models, which we are using, like it may be Open AI models or Coherence or the AWS model or Google models or Meta models, whatever generative AI models that we use, they are pre-trained models. They are pre-trained models. They are trained with the internet data which is available in the internet. They know the general informations available on internet, but they don't know the informations about a specific organization's internal details. They may be able to understand what is that organization or what service that organization is providing, but they don't know what are the different products and services they offer, right? For example, if I am planning to use a generative AI model inside my application, simply I can show you an example. So this is a Copilot, which is a generative AI based chat agent. So I am going to ask about my company. Okay. Hmm. Tell me about, or maybe I'll ask about some other company first. Tell me about Oracle and their services. So since Oracle is a very big company which has presence in uh, multiple areas, the information is available on internet about their global products and services. So the model is able to answer that because this is a publicly available information. What is Oracle and what are the different services they are providing? But if I'm asking about our company, so we can say, tell me about Synergetics India Private Limited and what are the services they offer. So this may or may not answer my question because our company is also a well-known company in India, and our company website contains the informations about the common products and services that we provide. So and let me ask whether it is no or not. You can see this is the information about Synergetics India Private Limited, and it's giving the informations which is available in internet. You can see this is the informations available on our website. Okay, so by referring to the website, it can answer this. But what if I go and ask who is the sales officer in our company, or what are the employees salary policy in our company? Or I'm asking another question is like, tell me about the reimbursement policies for employees. in Synergetics India. So it may not be able to answer. Tell me about the employees reimbursement policy in Synergetics India. Can you see it's just saying I couldn't find specific details about this company because this information is not publicly available in internet. So it knows the basic informations about the company because that is a internet data. It knows, it is able to identify. But if I am asking about the specific informations about the organization, like what are the different products and services they offer, what are the trainings they offer, what are the sub teams they have, in each team what are the different practices they have. So these informations it cannot provide because these are internal informations which are not available in internet. But what if I want to create a chatbot which needs to answer this kind of queries? For example, I have to go and ask, okay, I want to talk to the sales manager of Synergetics India, give his phone number, or which kind of training is provided by Synergetics for Python full stack applications, or what is the course duration for the mean stack applications. So, so these are the informations which I want from the Synergetic because maybe other training companies also providing the similar trainings. So I want the informations from Synergetics. So in Synergetics, what is the Python trainings duration? What is the cost for that? Or who is the CEO of the company? So if I have to know these informations, this generative AI model cannot answer that. But I want to create a chatbot which can answer this kind of queries. But how? That is what we are going to look. But before moving into the generative AI models, we need to understand a couple of key points about generative AI model. Specifically, we are focusing the GPT model from OpenAI. So in GPT models, what are the primary key points which we have to understand? First of all, there is an API key because every model or every generative AI model which are provided by various vendors. It may be a open AI model, or it may be a Llama model from Meta, or it may be a Google's model like a Gemini, or it may be a model from Microsoft. So all these models are accessible over internet as a REST API. So you can make a request to these models using an endpoint, and these models will return the response back to the user. But to understand whether the request is coming from an authenticated user, we have to use an API key. So API key is a secret or an authentication token that we have to provide along with our request. So whenever the request goes, it send the key along with the request to the API endpoint. So the API will understand that, okay, the request is coming from an authorized user or subscribed user. So it will execute the model and generate the result and send it back. Second thing is prompt. So prompt I have already explained. It is the text or it is the instruction sent to the model for generating the responses. So if I have to draw an image, or I have to write a blog, or I have to generate some test data, we have to write that instruction to the model. So model understand that instruction, that is prompt, and then generate the result. Completion endpoint. So I said these generative AI models, whether it is Llama, Gemini, or OpenAI models, or any other models, they are publicly available in internet. You have to access them via an endpoint. Endpoint is an HTTP endpoint. So these HTTP endpoints are called completion endpoints. Okay. So every model will have a different URL pattern or request pattern, but everyone is accessible as a REST API endpoint. Another thing is a token. So as a user, whenever you communicate with the generative AI models, you will be sending some instructions to the model via the completion endpoint. So that instructions will contains multiple sentences, and each sentence may contain multiple words. So each one of this word is considered as a token. So a token means a group of characters. So it can be a single word or it can be a part of the word. Suppose if the word length is bigger, then it may split the word into multiple tokens. So a token is typically one to four or five characters. You can say maximum five characters is one token. So if a word which contains 10 characters, then it may split that into two tokens. Okay, like that. So anyway, the token means the words that we are sending to the API. So why token is important? Because most of these generative AI models, which are uh, charging to the customer, or which for which we have to pay the amount or the cost, that cost is calculated based on the number of tokens used. So tokens is not only for the input request, even completions response tokens also be used or calculated. For example, if the response is containing 500 tokens, mean 500 words, then what is the cost for 500 token will be charged. Okay. Or if the request contains 100 tokens and the response contains 500 tokens. So total 600 tokens used for the execution. So in that case, you will be charged for that 600 tokens. So input request contains some tokens, that is the prompt tokens and the completion tokens. Both will be counted for calculating the cost. Temperature is a parameter that we can configure while making the request. So temperature is a numeric value which you can configure between 0 and 1. Its value is between 0 and 1. So what is 0 and what is 1? If you set the value to 0, its answers are more static or predictable. Okay. But if you set the temperature value to 1 or near to 1, like 0 0.7, 0 0.8, 0 0.9, or 0, or 1. So in this cases, the value can be more creative or dynamic. So it may not give you the answer, may not give the same answer every time. For example, if I am asking, okay, tell me about the reimbursement policy about the company. If I'm asking this question, if I'm setting the range of the temperature as 0 or near to 0, like a 0 0.1, 0 0.2, It is more static type, which means what is there inside the policy document, the exact same answer will be provided. There is no change. Suppose if there is a paragraph which is talking about the reimbursement policy, so it just give the reimbursement policy text as it is to the customer, or maybe making some changes in one or two words and then giving to that. So it's a more static answer. But if you set the temperature value to 1 or near to 1, and you are asking the same question, like what is the employee's reimbursement policy, then it will read the paragraph from your product manual or policy document and then creates its own sentences, means interpret that into a different set of sentence and then answer it. So the meanings of the sentence will be same, but the sentences will be more creative. Okay, so it is creating the answer by adding more sentences or by changing the sequence of the sentences, means it will become more creative and then answer it. Okay, but in such cases like where we have to provide the information from some document, then it's better to set the value as 0 or near to 0, because we don't want to give creative answers. We have to give a whatever is the actual information or answer in the document, that same answer we have to provide. So whenever you create custom chat agents, better to set the temperature value of the request as 0 or near 0. And the last point is about the models. So when you work with the generative AI applications, you will be using one or more generative AI models. Okay, depends on your use case. So there are different vendors available for generative AI applications. It may be the OpenAI or Microsoft or Llama or Google, etc. So here we will be focusing, since this is a Microsoft platform or Microsoft service we are discussing. So we'll be talking about the Azure Open AI models. The Azure Open AI models is actually providing the same set of models provided by Open AI. So Open AI is a different organization. They are developing generative AI models, like you know about them, like GPT models, DAL-E models, or embeddings, Whisper, and GPT, right? So GPT 3.5, GPT-4 are text generation models. DAL-E is an image generation model. Embeddings, which is very, very important, and we are going to use that in our demos. So embeddings is a model that is used for generating the text embeddings, and the Whisper 3 is used for generating the audio. So here we need to understand what is GPT model and what are the types of GPT models available. So primarily, if you are a open AI generative AI model user, you will be either using the GPT 3.5 models or the GPT 4 model. So GPT 3.5 is one of the widely accepted or widely used model. Okay, because this is very fast in response and more creative. Okay, so GPT models can understand the text input. So you have to give your request as a text. Means your prompt is always a text prompt, and it generates the text outputs. There are various versions of GPT 3.5 is available. like a GPT 3.5 Turbo, which is one of the most commonly used GPT model. And this is very cost effective because this is very cheap compared to GPT-4. Okay. So this is typically used for chat applications. Means if you are planning to create an internal chat agent, then you can use the GPT 3.5 Turbo model. But the GPT 3.5 Turbo model's problem is its a context size is small. Context size is important because whenever you send the prompt, means instruction, along with some reference data, how much data you can include in the context, that is important. Suppose if you are able to send only less number of tokens to the model while sending the request, so you cannot express all your requirements, right? So such cases, the it will affect the response, the accuracy of your response. So GPT 3.5 Turbo uses a 4K as its the context size, which means 4,000 tokens in as the context size. So problem is the amount of data that you can include in the request is very less. Okay. So as a solution, they have introduced a new model, which is a 16K model, which is GPT 3.5 Turbo 16K, which is providing 4 times more context length, which means this has 16,000 tokens you can include in the context. For example, if I have to provide a request to the model along with some sample data, so I can include a very large set of data because 16,000 tokens are now supported in the context. So if you are planning to use very large context data, then it's better to use which one? GPT 3.5 Turbo 16K. There is another model which is available, that is GPT 3.5 Turbo Instruct, which is providing non-chat endpoint, that is a completion endpoint, which is uh, not using a chat message format. If you look at the GPT 3.5 and the GPT 3.5 Turbo 16K, they are using a chat request model format, which means the user is interacting with the models or the generative AI models using a chat message format. But GPT 3.5 Turbo Instruct is a is using a legacy approach, which is using a completions API instead of chat completions. I'll show you. But before that, there were some legacy models were also available, like a DaVinci models, okay, Code DaVinci, Text DaVinci, and so on. So but GPT-4 models are newly introduced models. So you can see now there are different variations of GPT-4 models available, which are GPT-4o, GPT-4o mini, GPT-4o vision preview, and so on. So there are lot of versions of GPT-4 released. Okay, so what is the benefit of GPT-4 is this is providing more accuracy than GPT 3.5 model. But the problem is GPT-4 model is little costlier than the 3.5 model. As a solution to to reduce the cost, they have introduced the GPT-4 O mini model. Okay, but GPT-4, if you use, you can see it's a providing a very large context size. So you can see it provides various types like a GPT-4 with the 8K tokens, GPT-4 with a 32K tokens, and GPT-4 Turbo with a 128K token also available. Another important feature of GPT-4 is it is a multi-modal model, means it accepts not only the text data, it can accept even image as an input. Okay, so it can analyze the image and generate the responses. So if you use GPT-4 Turbo Vision Preview, it is able to accept even images. Okay, so now GPT-4o Mini or GPT-4 401 kind of new models also introduced. So you can check the OpenAI's catalog to understand the differences between these models. So as a developer, if you are planning to create chat applications, as I have mentioned, you have to understand the endpoints. Endpoints means the URL endpoints where you are making a request so that the model receive the request and execute and response. So if you are an Azure Open AI user, you have to send the request to this given URL. So your URL is always like this. Okay. So endpoint is the name of the service that you create or name of the OpenAI service that you create. And then .openai.azure.com/openai/deployments/deployment name/chat/completions. Okay, so this is the complete URL that you have to use for making the request. But nowadays, nobody is using the REST URLs like this completely. Instead of that, we can use the SDK. Means if you are a Java or .NET or Python developer, there are programming libraries available. Through the library, you can make a request. So the library internally invokes this REST API endpoint. Means as a user, you don't need to make REST API request directly. Instead, you can use the SDK, and the SDK will internally communicate with the REST API. So REST APIs are mandatory, but the user is not going to directly interact with the REST APIs. And another important thing, since we are using the chat completions endpoint, we are sending the request in the form of a chat message. So in our demo also, I'll show you that how this chat message is used. You can see here we have a role and a content. In every message, we have a role and content. Role can be either a system or a user or an assistant. You can see there are three type of roles. One is system, second is user, and the third one is assistant. System is typically used once in a conversation. So that is typically used to set the behavior of your AI model. So you are instructing the model that how you have to behave. So you can say, okay, you are a strict police officer. So answer the questions like a policeman. Or you can say, you are a teacher. So answer the questions like a teacher. Or you can say, you are a comedian and you have to give the answers like a comedian. So you are setting the behavior of the AI model by using the system message. And in the user message, you will be asking the question that you want to ask to the model. And there is a assistant message. The assistant message is a response which is sent from the AI model. So for example, I can show this in the Azure Open AI's playground. So if I go to the Azure, and here I have already deployed an Azure Open AI instance. So this is an Azure Open AI instance. And here we can see the Azure AI Foundry portal, which is giving you an environment to work with the Azure Open AI models. I have already deployed some OpenAI models. Can you see here? I have deployed GPT 3.5 Turbo 16K model as well as GPT 4o mini model. And there is a text embeddings model. So there are three models I have deployed. These two are GPT models, and this is the text embeddings model. What is text embedding? I'll explain later. But as of now, we'll look into this GPT models. So to test this GPT models, I can come to this playground. In the playground, you can select the model, which model you want to test, because these two are text models. So I can select GPT-4o mini, or I can select GPT 3.5 Turbo 16K. So I'll select GPT 3.5 Turbo 16K. And here is the system message. So here you can define how to answer or how to behave. Okay, so that means you are asking the model how to behave or how to answer. So you can see this is a default system message, like you are an AI assistant that helps people find information. Okay, and this is our chat window. User message we are typing here. Okay, so this is a system message and this is the user message. See, I am going to ask a question like how far is moon from Earth? And the assistant message is coming here. You can see there's a standard answer coming, right? The average distance from Earth to moon is about this many miles, right? Very simple answer. Now, if I go and click on this view code, and if I go to this Python, you can see the message structure which is created in the chat prompt, role equal to system, and this is the system message. And this is the user message where I have asked how far is the moon from Earth, and the assistant has replied what the average distance from moon Earth to moon is so and so. So this is the communication which has happened, right? Now I just clean up this and I'm going to change the system message because I want to show you how the system message is changing the behavior of your model. See, you are and you are a comedian who answers the user's questions in a funny way. Include jokes with the answers. So I'm giving an instruction like you have to behave like a comedian, okay, while answering the user's questions, and you have to include some jokes inside the answers. Okay, so I can save this. Now I'm asking the same question. How far is moon from Earth? See, this is the actual answer which is coming. Okay, that is this many miles away. That like a really long distance relationship, but luckily they still see each other every night. You see, this is including a joke at the end of this answer. That means it is giving the answer, but it is also including a joke at the end because this model is now behaving like a comedian, so he can answer in a funny manner, right? So this importance of system message is that you can decide or you can inform the model how to behave. Okay, so you can write, okay, you are a police officer answer the questions in a strict way. Okay, like that, you can change the behavior of your model. Okay, so that is the chat completions uh, endpoint. Okay, so here you can, if you click on this, okay, you can see this is the endpoint URL. Okay, you are sending the request to that endpoint. So here it is using what? The SDK. Okay, not the REST API. So REST API, yeah, this is what the REST API URL. Can you see? Synergetics oai.openai.azure.com/openai/deployment/name of the deployment/chat/completions. Okay, so that is the URL that we use typically for making request. The next is embeddings. Okay, so what is embeddings? So embeddings is very important for us because in our case, in our session, we are using this embeddings in our database. So embeddings are numerical representation of the text data. So whenever the generative AI models handles this data, it do not handles the text data as it is. It is handling the embedded data or the vector data. Okay, so these embeddings data means any text that you provide is then converted into a numeric representation of that. So here you can see we are providing a text data to the embeddings model, and the embeddings model is generating its a numeric representation. So this is called a vector data. So for doing this, we use the embeddings models. So there are different embeddings models available. So we have embedding text embeddings ADA 002 available. We have text embeddings 3 large available, text embeddings 3 small available. So what is the difference between them is the amount of data it handles and the number of dimensions that they have. Okay, so every embeddings model is actually creating a numeric representation, which is a multi-dimensional vector. So suppose what is this? What is the benefit of this embeddings is whenever you convert your data into numeric representations or embeddings, it plot your data into a multi-dimensional vector where the similar or which has semantic meaning, same semantic meanings will be plotted together in the same place. Okay, for example, can you see this green? This is all green, which is coming together because athlete is the word or any word that is similar to athlete or maybe a sports person or athlete or maybe a player. All these are similar meanings, right? If you say player, it's an athlete, or if you say athlete, it's a player only, or sports person. That is again has similar meaning of athlete or sports person or player. Okay, so they will be put in the same place. You can see they have some their distance is very less. Can you see? Because their meaning is same, so they will be put in the same place. Similarly, animal. So animal is represented in this color. You can see. So this may be dog, cat, elephant, tiger, lion. Okay. So these kind of animals will be placed in together, or any word that is representing the animal comes here. Okay. Similarly, village, transportation, film. So these words or sentences that has similar meanings will be plotted in this uh, multi-dimensional vector within the same space. So if you go There is in Open AI, they have given this diagrammatic representation. So here you can see. So this is a multi-dimensional vector you can see. See, the data is plotted like this. This is so this is a sentence which is talking about some sports person, I think, right? Yeah, athlete. So who won the Danish national and international championships from the early 1970s. So it's talking about a sports person. Means there's a sports related information. Suppose if I come here, this is again a sports related information. So Japanese professional baseball player. This is again Dino Bivab, a Bosnian football player. So this is again football player. This is Serbian football player. This is midfielder who currently plays for so and so. So all the sports related informations or data comes here. But if I come here, you can say that this is animal, right? So some animals information is here. Some animal is living where. So this is Sienna pallidi is a moth. This is so this is another information. So you can see these all animal related information which are placed in nearest places. So this is another set of data which is talking about village. So this is a village information. This is another village information. This is another village information. So these informations are placed together. So if I'm searching for a village, it will go and find this matching informations. Okay, from this place. So this is how the vector data is get stored. So for generating this vector data, we have the embeddings model, and this is the embeddings endpoint. So whenever you make a request for making the embeddings, it's we have to make a request to this endpoint. So usually we don't need to go and make the request to this endpoint REST API endpoint. We can use the embeddings SDK. So there is classes and functions available for creating the embeddings, which internally calls this API for creating the embedding. So if you are a developer who wants to manually invoke this and generate the embeddings, this is how we have to do. You make a request, you are passing an input text. So this is the input text that you are passing, and response will be like this. So it returns a data array. Inside the data, you have the embeddings. So this is the vector embeddings representation. So if you are using text embedding ADA002 model, the number of numeric values which is coming inside this is 1536, which means these many dimensions it supports. But if you are using a text embeddings 3 large, it is supporting more than 3000 dimensions. Okay, so that means different embeddings model have different capabilities. So some models can generate high dimensional vector data. Some models can generate less number of dimensions data. Okay. So you can see this is generated using which one? Text embeddings ADA002. So how many numeric values comes inside this? It will be 1536 dimensions. Now we are going to talk about the next point, that is vector databases. After this topic, we'll take a small break, and also you can put your queries, anything you have. I will answer your queries up to this because this is what the base we are setting for the actual topic. So vector databases. So in the previous section, we have discussed about the embeddings model. So what is this embeddings model's usage? We have to convert our text data into numerics because this numerics data is used by the AI models to search and find the matching answers. As you can see, suppose this green one is talking about athletes, which means these all informations are related to sports or athletics. Okay. Suppose if I make a query for finding some athletes information. Okay, tell me about a particular athlete name I'm specifying. Okay, tell me about this particular athlete. So then what happened is the Gen AI model needs to go and find information from this area because this is the sports persons or athletes information stored, and we have to find the matching answer and then generate the responses. But the question is, will that AI model, that is generative AI model, can do a database search or can do a data search inside somewhere? No, it cannot do any search because it's a pre-trained model. So the pre-trained model means it cannot go and search anywhere and find the data. Okay. So what we are supposed to do is, what is the data we are planning to give as a contextual data, or what is the data we are planning to give as a contextual data? So that data we have to store somewhere and then give to the model. So now you may be wondering, what is this contextual data? So what is this contextual data? I'll just explain in one example. Suppose here, I'm not sure whether uh, it is able to answer. Let me ask a question about myself. Can you tell me about, I think this is taken from the LinkedIn or somewhere. Okay, from GitHub. Okay, suppose if I am going to ask uh, some information about a particular employee in Synergetics. Okay, for example, uh, tell me the experience and the skill set of Mr. Kumar, who works in Synergetics. So now it says it don't know anybody with the name Kumar in Synergetics because they don't know, the model don't know anything about the employees in Synergetics, right? So what I am planning to do is I am giving a base information. Okay, for example, let me open a notepad. So I'm just trying to give some information like Kumar is an experienced Java trainer who delivers sessions for various clients on Java technology stack. He is good in Java Spring Boot, EJB, JPA, and Oracle. He is also good in front-end technologies like Angular and React. So this is uh, he has total maybe 6 years of experience. I'm just giving some information. Now another employee, maybe Mr. Sagar is working in Synergetics as a uh, open source trainer who deliver sessions on Python and JavaScript technologies. So like this, I can create informations about the employees. Now what I'm going to do is, okay, consider, I'll create here the prompt here itself. Consider the employees information in Synergetics. Okay. And then this is the employees information. And then I'm going to ask a question. Tell me about the technologies uh, Sagar is teaching. Okay, so this is my question. So I'm just giving this as a context data and then asking a question. So I have already given the context data. Based on this context data, it generates the answer. You see, the information what I have given is very less, okay, but it is generating an answer based on that. This is a completely new paragraph or new information which is generated by Gen AI model based on the information I have given. Now it's not saying I don't know who is Sagar. And again, I'm asking, tell me about the Java technologies or about uh, Sagar, sorry, Kumar and his skill set. Now we can see it is able to answer who is Kumar. Right? Previously, when I asked the same question, it is saying, no, I don't know who is Kumar. But now it is able to answer because I have already given some information in the context. Okay, so this is my context data, and all my questions are related to that context, right? So I am not modifying the Gen AI model, or Gen AI model is not going to connect any database or fetching the data. Instead of that, what information it has to use as a reference, I am providing that information. Then I'm asking the model, okay, I have given you some information. Based on that, you need to answer my question. So now if I ask questions, it will go to this contextual data. And then if it is included here, if that information is here, then it will answer it. Okay, so maybe I can go and ask, can Kumar teach Angular? Now say, yes, Kumar can teach Angular. As mentioned earlier, he is good knowledge in the front end technologies like Angular and React. See, all my questions are now answered based on the contextual data, right? So this contextual data we have to provide to the Gen AI model, because Gen AI models cannot connect to a database and fetch it. We have to provide the contextual data. But the question is where I can store this contextual data. Somewhere I have to store this information, right? And not only storing that contextual information, we have to go and search and find the matching information, because I am not making any SQL queries to search and find the data, because this is a complete textual information. So I may be asking the question in any format. Maybe I'm asking, okay, tell me about Kumar, or can you tell me about Kumar's experience? Or I'll say, explain the skill sets of Kumar. So my question is in a natural language format. So it can be in any syntax or semantic, but the meaning of this question is same. So what I want is I have to go and search the information about Kumar and then give that information to the model so that the model is able to answer it. So here I have given some contextual data to the model. So model is able to answer that. But to do that, I cannot provide this data every time like this. Okay, every time I cannot provide the data in like this hard coded. So somewhere I have to store that data. Okay, somewhere I have to store the data. All my employees' data is maybe in the PDF document, or maybe in a JSON document, or maybe in some other data storage. What I have to do is I have to store these informations in a special type of database, which is called a vector database. So why? Because whenever I want to use the data as a contextual data to generative AI models, it has to be a searchable data. If it is not searchable, it cannot go and fetch the matching informations about related to my question. Suppose if my question is about Sagar, it has to go and search the informations about the Sagar and then provide as a contextual data. If I'm asking about maybe Kumar, then it has to go and search about Kumar and give that information to the model. So if there are 100 employees in the organization, I cannot give 100 employees data together as a contextual data. Instead of that, what I do, if I'm asking about Sonu, it will go and search about Sonu and give that information to the model. If I'm asking about Ajay, it will go and search about Ajay and then give that information to the model. So giving all 100 employees data like this is not possible. So we have to go to the database, search and find the matching information and provide that matching information as a contextual data here. So now the question, if I have to search and find this matching information, somewhere we have to store this data, right? So for storing this data, we use the vector databases. Now the question, why vector databases? Why can't we use the normal SQL or NoSQL databases? The problem is here we are doing the search based on the natural language text, not as a SQL query. In SQL query, we are searching based on a particular column value, right? So select star from employees where employee ID equal to so and so. Okay, or where select star from employee where department equal to IT or marketing. So where we are searching based on a column value. But unfortunately here the data is not in a table format. So you cannot use SQL or similar kind of query mechanism to read the data. Here, my data is a complete text data. It's a paragraph. A paragraph about Kumar, a paragraph about Sagar, a paragraph about Ajay, a paragraph about Sonu. So then how we will go and find the matching data from there? So we have to vectorize. Vectorize means we have to convert your data into numeric value, that is embeddings, and store inside the database. So embeddings we have discussed here. So when you convert the data into embeddings, similar informations it will go and store inside the vector like this. Okay. So we need to create the numeric representations of our data and then store that data inside the database. So here you can see for that what we do is we will read the data from various sources. Maybe my employees data I have in a PDF document, or I have in a JSON document, or I have in my SQL database, or in website. So somewhere I have my employees' data. So it may come from any of this data source. We will load this data using some Python code or C# code. We read that textual data. So this is my textual data, which is a very lengthy textual data. First step, if we have to split the data into multiple chunks. Chunks means it is not possible to store the whole data in one go. So what we can do is we can split the data into small chunks or pieces. So that is called a transform. So in the transform state, we split the data into multiple chunks, and each chunk of data is then embedded. Each chunk of data we are converting into numeric data, and this numeric data is stored inside the vector store. So for converting this text data into embeddings, we use the embeddings model, and that converted numeric data we store inside a database. So this database is called a vector database. This vector database is a special type of database which is different from the traditional SQL or NoSQL databases, because here we are storing the vector data. And not only that, it now supports vector search. Vector search means whenever I search for a text, it is actually searching inside this multi-dimensional vector for finding the matching answers. It's not like a keyword search or a column-based search. Okay, so here is a vector search. So search is happening inside the numeric data to find the similar or matching answers. Once that matching data is returned, so we are searching inside this numeric data, but we have to get the textual representation of the data. So inside the database, we should have the textual data plus vector data. So searching is happening on the vector column, but what it returns is the text column. Okay, like we are searching for the employee ID, but what we have to return is the employee details. We don't want to return the ID. So we are searching using the ID, but we have to return the employee's data. Similarly, we are searching inside the vector data, but it returns the textual data. So these textual data is used as a context for our generative AI models. So this vector store is one of the most common ways to store and search over unstructured data, is that is embedded it and store the resulting embedding vectors, and then at query time the embedded unstructured query and retrieve the embeddings vectors that are most similar to the embedding query. So whenever the user makes a question, okay, it will go to the vector database, search the matching answers, and returns it. Here you can see we are loading our data, transform it, embed it, and store here. So my complete text data plus vector data here. Then whenever I make a search using a query, maybe I'm asking a question like how far is Moon, or who is Sagar, or who is Kumar, what is his experience. So this kind of questions I give, that question is first converted into number, because if I have to do a search, we have to convert our question into embeddings or vector. So then it will do a search inside the database, find the matching documents or find the matching text informations, returns that text data. So this text data we can use as a context data. So I have already explained what is context data. So we use this context data inside our Gen AI models. So there are different vector databases available. So like Azure Cosmos DB for MongoDB, Azure Cosmos DB for NoSQL, Fias, Chroma, Milvus, Pinecone, Elasticsearch, and many more. Okay. So these are different types of vector databases we have. So you can choose any of these vector database. Some of them are persistent storage, some of them are in-memory storage, like a FIAS, which is Facebook Artificial Intelligence Similarity Search, and Chroma. So they are primarily in-memory based vector databases. But Pinecone, Milvus, Elasticsearch, Cosmos DB, all these are persistent storages by default, which means they store the data into some physical storage. So that's the basic information about the generative AI models, embeddings, and the vector databases. Now we are starting with the Cosmos DB for NoSQL. But before that, we will take a 10-15 minutes break so that we can have some tea or coffee, and we will continue after that. So if you have any questions, you can post your questions in the chat. So I'll try to answer that questions at the end. Okay, here is already a question. We have to use AI Foundry only for using Azure Open AI service. No. Azure Open AI Foundry is just to try test your models using a web portal. If you are a developer, you can create your application, and through the application, you can do everything by code. So if you are a fresher or newcomer, just to try out the scenarios, how it is working and what we can do to understand this, we can use the AI Foundry portal. Foundry portal is not mandatory. So you can deploy the model, you can create the application by code, and you can consume this model all by using the applications like C Sharp or Java or Python. So what is GPT key concept? So are you talking about the authentication key? If that is the question, so whenever you subscribe to a GPT model, or whether you are subscribing the OpenAI GPT through the OpenAI site or using the Azure, they will be providing an authentication key. So whenever you make a request, you are supposed to send the authentication key along with the request. Okay, that's what that means. Otherwise, the uh, server will not understand whether your request is coming from an authenticated user or not. So you have to send your authentication key along with the request. So if you are a subscribed user, you will be getting an authentication key. Yeah, if we use SDK, then AI Foundry is not required. Yes, not required. By code itself, AI Foundry you can just use to deploy the model. Okay, because it is the easiest way. Even code wise also you can deploy the model, or you can use the CLI command to deploy the model. It's possible, but it's better to go to the AI Foundry, deploy a model, okay, like a GPT model or something, but consuming that model through the application, that you can write a Python application or Java application or .NET application. Through that you can consume it. So whatever you do in the Foundry, you can do using a code. So why Foundry is because without writing code, if you want to try out some of the features, or you want to see how it is working, okay, how or what I can do with that models. So if you want to try out some of the features, why you have to create a chat application? they have already providing a chat window. So try out that. So you will understand what are the things possible. Once you understood, okay, you can go and create your own chat window or a chat application. So RAG and GAN model. So RAG is an approach. Okay, so retrieval augmented generation, which we are going to discuss after the break. Okay. So that time I hope that will answer your question. Now let's take a 10 minutes break. Hello, everyone. All are back. Okay. What about others? Okay. I think we can continue. Just give me a minute. Okay. So I hope the screen is visible. So we have discussed what is vector database and what is the importance of context in generative AI conversations. Now let's understand this Microsoft product, that is Azure Cosmos DB for NoSQL. The Azure Cosmos DB is a multi-model database service. This multi-model database service supports various NoSQL database types like key value database type, document, that is JSON documents type, graph database type, and a column family. So document database is one of the most popular type of NoSQL database, which stores the data in JSON format. But we also have key value pair data store, which stores the data in a key value format like Redis database. We also have a column family type data, which is Cassandra, and also graph. So Azure Cosmos DB supports all these types of NoSQL data. So that's why it is called a multi-model database. Now, specifically focusing on the document storage, there are two types of NoSQL API supported by Cosmos DB. One is MongoDB, and another one is Azure Cosmos DB for NoSQL. So both are storing the data in the document format. MongoDB is one of the popular NoSQL database, which is used by many organizations in on-premise, and now we can use in cloud as well using the Mongo Atlas. But if you are a Microsoft Azure user, if you have to use the MongoDB, you can use the Azure Cosmos DB for MongoDB because it provides the MongoDB API. So migrating the MongoDB applications to the cloud is now very easy. And MongoDB, Azure Cosmos DB for MongoDB is already supporting vector database. Okay, because MongoDB is already providing support for vector data storages. But now Azure Cosmos DB for NoSQL also supports vector storage, which is a new feature they have introduced in Azure Cosmos DB for NoSQL, which now supports vectorization. If you look at why Cosmos DB is required, because It is a globally available data storage, even though we have many other vector databases available, like in the list I have showed you, Milvus, Pinecone, and many other. Then why we have to use Cosmos DB? Because Cosmos DB is a highly available database. It is replicated across geographic regions, and it is providing single digit millisecond latency or single digit millisecond response time. Means its a response time is very high. It's a highly available and provides high throughput for user queries, and it is providing SLA for throughput, consistency, availability, and latency. That means uh, you typically for cloud services you will get SLA, that is service level agreement, only for the high availability, but Cosmos DB is providing SLA on various parameters like throughput, consistency, availability, and latency. So simply say Cosmos DB is one of the popular database that we typically use for the mission critical applications like gaming, robotics, IoT scenarios, and many more. So in Azure Cosmos DB for NoSQL, how we organize the data. At the top level, we have the database account. So we create a database account in Azure. So we have to first create a database account. Once the database account is ready, then we can create a database inside it. One or more databases can be created within an account. Inside each database, we can create one or more containers. So container is means collections. Okay, if you are a MongoDB user, we can easily understand container means a collection, like an employee collection or products collection, students collection, so on. So it's like a table. Okay. Inside the container, we have the items. So item means the documents. Each document is called an item. So a document looks like this. So this is a sample document structure. Every document will have a ID and a partition key. Okay, every document will have an ID and a partition key. So this is the structure of Cosmos DB. If you look at this, I can show you in portal. So I have already created one Cosmos DB account. So if you want to create a new one, then you have to go to the databases. So from here, you can select a Cosmos DB account. So you can see primarily there are two APIs recommended. One is Azure Cosmos DB for NoSQL and Azure Cosmos DB for MongoDB. But we have other APIs as well. That is a key value storage like a table, Gremlin, which is a graph database, and Apache Cassandra, which is a column family type. And also now it supports PostgreSQL, NoSQL type for the relational database. So now inside this, we are supposed to create a NoSQL type. So Azure Cosmos DB for NoSQL. So we can create this. While creating, you have to specify whether you are looking for dev and test environment or production or learning purpose. So if it is learning, then it will create the instances with a low configuration because we are using it for the learning purpose. Then you have to select your subscription, a resource group, then specify an account name and a location. Okay. And you can specify a throughput model, that is provisioned throughput or serverless model. So serverless is fine because we are not allocating any dedicated capacity. Okay. Based on the requirement, it automatically allocate the capacity. But in provisioned throughput, we have to pre-allocate the capacity. Okay. So we go with the serverless model. Then we can have geo replication feature, which if you want, you can enable that feature. Multi-region writes, you can enable. Networking configurations means now by default, this CosmosDB account is accessible from any network. You can also configure the backup policy, configure the encryption and tags. Then you can create it. So I'm not creating this because I have already created one account. So here, this is my account. This is the account which is at the top level. So Sonu hyphen vector DB, that is the account that I have. This is the account. Inside the account, you can create one or more databases. So you can go to the data explorer. Currently, I don't have any database or container. So I can select from here new database. So I can say DemoDB is my database. Sorry. Taking time. Okay. So you can see it's created. Inside this database, I have to create a container. So I can specify a database that is DemoDB. Inside this, I can create an employees container. And I can also specify a partition key, like maybe department as the partition. Now, if I click on create, it's going to create a container. Inside this container, I can create the documents. So here at the top level, we create an account. Inside the account, we create a database. Inside the database, we create a container. Yep, you can see the container. Now, inside this container, we can create the items. So new item. So each item will have a ID and a partition key. So ID will be auto-generated, so I'm not inserting that. ID should be string value. Okay, so I'm not putting this. Department I can say as IT. Then employee name I can say Kumar. Then email Kumar at example.com. Then mobile so and so. So like this, I can put the data and save it. You can see it creates the document, but you can see some extra values are added by CosmosDB. So this is automatically added by CosmosDB. Okay, so that we don't need to worry. ID is auto-generated, and these are the values that I have stored. So whenever we create a container, it automatically index the data also. So every container has its own indexing policy also. See, this is what the indexing policy. So what is the indexing policy? We'll discuss later. So currently, I'm not discussing about this. We have a separate topic for that. So anyway, it automatically index the documents that we create based on each and every field. Okay. So this is the Azure Cosmos DB for NoSQL structure. And we are using this uh, Cosmos DB account, that is the Azure Cosmos DB for NoSQL, we can use for various purposes because it provides different features. So what are the different features that it provide? It's more flexible, has a low response time. It's a globally available one. It is a vector database. That means it now supports vector database, and this is what we are focusing now. Okay. And it processing transactions at a massive volume or velocity. That is high volume of data it can process in less time. Elastically scalable to meet the application needs means it can increase the throughput based on the application requirement. So these are some of the features of Cosmos DB, but our focus is currently on the vector database functionality. And we can use Cosmos DB for various scenarios. We can use it for web applications. We can use it for IoT, gaming, mobile. But our focus is generative AI. So this is our use case. So we are using Azure Cosmos DB for our generative AI application, and we are using it as a vector database. Okay. So this is our applications use case. Now, we have just created the Azure Cosmos DB for NoSQL. But now the question is, if I have decided, okay, I want to use this NoSQL, means Azure Cosmos DB for NoSQL database with my AI application, generative AI applications. But why? Why we have to use it? I have already explained that we can use it as a vector database for generative AI applications. So before start using that, we need to understand how we can customize our GPT responses. Suppose if I have to create a generative AI application with some custom information rather than the trained data, what are the different ways we can customize the model? Because the model is capable to answer only based on the trained data. But other than the data, if the model is supposed to answer some specific information like organization specific information, domain specific information, person specific information, if it has to answer that, then we have to customize the model. So what are the different ways to customize the model? For customizing this model, we have different options. The first option is few shot learning. Okay. So few shot learning means we are going to use some of the prompt engineering techniques to customize the responses. Okay. Or we can use fine tuning. Fine tuning is another approach of customizing the model. And the third approach is RAG, where we are using the vector databases. Okay, so how we can customize the models? The first option is with a prompt engineering and a few shot learning. So for that, we have to understand what is prompt engineering. So prompt engineering means it is the method of writing an effective prompt for getting relevant and accurate results. Suppose if I am expecting the model to generate a response which is more relevant and accurate based on my scenario, I have to write a prompt which the model can understand and generate the responses. So how we can write effective prompts, there are some techniques used for writing effective prompts. So that techniques collectively called as prompt engineering. So there are many approaches, many techniques used, but we are not discussing all these approaches here. So prompt engineering is the way or is the approach to enhance the prompt or to write effective prompts. So one of the important is few shot learning. But for understanding few shot learning, couple of prompt components you have to understand. So first of all, what is a section marker? What is primary content? What is supporting content? And what is grounding content? Section marker is either a 3 hyphen or 3 hash, which is used to separate the topics or separate the elements within a prompt. So if you write a prompt, we will write separate elements within that. So first of all, we will be including an instruction. So what is an instruction? In this case, you can see that this is an instruction, which means what I'm trying to do with the generative AI model. So I'm telling the model, you have to do this. So that is my instruction. So this is my instruction. So tell me about the technology Sagar is teaching. So this is an instruction. Okay. But the thing is, sometimes in for executing the operations, only the instruction is fine or only the command is fine. Instruction or command or question is sufficient. For example, how far is moon from Earth? So this is an instruction or this is a command. In this case, I don't need to provide any additional information. Only the instruction is enough. Or only question or instruction. Okay, this is enough. But consider another scenario. I'm telling mm, create a blog about artificial intelligence, or maybe another thing is translate the given text to French. So this is my instruction. So translate the given text to French. This is the instruction. But only with the instruction, we cannot do anything. So I have given translate the given text to French. Then where is the text? Without the text, it cannot operate. So we have to give some additional information. For example, hello, how are you? Okay. So in this, the first line is a instruction or command or question. And the second one is the actual text content. Okay. So to separate them, we use the section marker. 3 hyphens we can use. So this is my instruction and this is my actual content. So this content is actually called the primary content. Because without primary content, we cannot execute this. If the model has to translate the text, where is the original content, original text? This is the original text. So without this text, it cannot translate into French. So to complete this operation, we need an instruction plus primary content. But here only instruction is enough. Okay. So consider another scenario. Another example is create a summary of the below text. So create a summary of the given text. But where is the text? So here below, we have to give the primary content. So here, this is the large text. So here, so and so you have to type. So here is the large text. This is the primary content. And this is the instruction. Okay. So some time when you make a request, only instruction or command or question is enough. But in some scenarios, we have to give the instruction plus a primary content. Okay. Sometimes sometimes the instruction is sufficient, but for giving more clarity, we can provide a supporting content. For example, create a blog about artificial intelligence. So I am telling the model, create a blog about artificial intelligence. So this is enough for creating the blog, right? There is no additional information required. So this is my instruction. This is sufficient. But this is creating a blog, but the problem is it may or may not include some important points, because I am planning to write a blog about artificial intelligence which talks about some advanced topics. Okay, so I can give some additional instruction like include topics such as vector databases, RAG, fine tuning, maybe, and LangChain. Okay, so here you can see, even if I'm not giving this line, still it works. But my expectation is write a blog about the advanced topics, not the basic topics. So I can provide some additional informations to provide a clarity on this. So this I can say a supporting content. So some cases only instruction is sufficient. Some cases instruction plus primary content is mandatory. Some cases instruction and a supporting content. Supporting content is optional. So without this also it works. But primary content is mandatory. Okay. In some cases, to work, we need to provide the contextual data. For example, this one. So this is the instruction or this is the instruction and this is the contextual data. So we are providing the context data. Based on this context only it is answering, right? So that is what we have to understand from this. So when you write a prompt, there are section markers, primary content, supporting content, and a grounding content. So inside one prompt, it not only contains the instruction, but also contains primary content or supporting content or grounding content. Grounding content is called the context data. Now, what is the importance of system message? I have already showed you the system message is typically used for controlling the behavior of the model. So here you can see when you send a message, you can include a system message so that you are telling, okay, the system message is telling the model that you are a casual, helpful assistant. You will talk like an American old Western film character. Means you have to answer like a old Western film character, how they speaks in the same accent or in the same way. You have to answer the questions. So then the user is asking a question, can you direct me to the library? And you can see the assistant is giving an answer just like a movie dialogue, right? Well, howdy there, stranger. The library, right? You can see the answer is coming like how the American old film character is speaking, the same way it is generating the answer, right? So system message is very, very important because based on the system message only the assistant is behaving or generating the answers. Next thing about prompt engineering is conversation history and few shot learning. So to make more clarity on the answers, we can tell or we can give some examples in the conversation. For example, if I go to the AI Studio So here I'm going to reset this. This is I'm setting back to the default message. So giving, uh, I'm changing the system message. You are an AI assistant that helps to analyze the sentiment of the user feedback. Okay. So I am setting this as the system message. So what is the model's duty? Model's duty is to analyze the sentiment of the user feedback. Okay. So now I'm giving a user feedback. I liked the movie very much. So you can see this is a lengthy statement coming, but ultimately my feedback is what? Positive. Okay. But why I need a lengthy sentence as a response? I need only one word, positive or negative. For example, if I say, I don't like it. So instead of giving this lengthy sentence, I need only positive or negative word. So what I can do to customize the response, I'll go to the sections and add more examples. So inside the example, I will say like, I don't like that movie. So here answer which is coming from the assistant is it should be in which format? So negative. Okay. So I can add one more example. Here I'll give another example. I love that. It's awesome. Okay. So this is the positive. If you want, you can include a more example. Maybe one more example I can add, like it's amazing, really worth watching. So this is again positive. So you can see I have given three examples in the conversation, right? So now if I save this, apply changes, I saved it. Now let me clear and start the conversation. So I have given three examples. Now, based on this example, I am expecting a single word answer. You saw the previously it was giving a lengthy sentence. Now let's see. Um, I am not satisfied with that. I'm not satisfied with that. This is my feedback. Now you can see instead of that lengthy sentence, only one word is coming as the answer. Or maybe it's a really worth watching it. See, it's a single word answer. So now you can see I have customized the default behavior, right? So I have not retrained the model. What I did is using the prompt engineering technique, I have given some examples. So the model is understanding, okay, I am supposed to answer this way. By looking into this example, model is understanding how to answer this. So if you look at this code, you can see here in the conversation history, we are including some examples. Look at this. This is the first example, second example, third example, right? So by looking into that, it is able to understand, okay, how to answer this. So this is the first way of customizing the model. So we are understanding what are the different approaches for customizing the model responses. The first way to customize the response is by using the few shot learning. Few shot learning means giving multiple examples in the conversation history. By giving examples, model will understand how to answer it. Okay, so that is the first way of customization. The second approach is fine tuning. So fine tuning is really a costly process, because whatever models we are currently using, like a GPT or GPT 3.5 or GPT-4, they are called base models. They are actually trained models, right? They are already trained with the internet data which is available. But what if I have to train the model, or what if I have to teach the model about my company information, like who all are the employees in our company, what are the skill sets of those employees, what is the company policies, or what are the departments in our company, what services they are providing. So means I want to teach the model about my company's information. So for that, I have to retrain the model. Means I have to retrain the model by passing the informations about my company. But the problem is all these base models are not supporting fine tuning. Okay, fine tuning requires, or fine tuning can be done only Fine tuning can be done only on selected models only. Okay, some of the models are supporting some of the models are supporting fine tuning, and also fine tuning requires high configuration machines. If you use a normal laptop, you cannot do fine tuning, because fine tuning requires high compute and CPU. So that means you need a GPU enabled machines, or high performance compute machines for doing the fine tuning. So fine tuning is a time consuming process. Yes, you can retrain the model, means you can create a new model, means by customizing the existing model, you can create a new model. But the problem is it's a time consuming process. It requires more effort. Okay. So organizations don't prefer that much, because uh, suppose if today I'm start retraining the model with the custom data, maybe after a few days, what if the data is changing? We have to retrain the model, right? So retraining will take time, and it is a costly process. So doing it again and again and again is not a good approach. So fine tuning is good if your data is static, means you have to train only once and you can use that model. Then in that scenario, fine tuning is better. But if the data is keep changing, then fine tuning is not recommended, because today if you are fine tuning, maybe after 2 days the data will change. So you have to again retrain. So retraining again and again and again is not a good approach. Okay. So in fine tuning case, what you have to do, you have to prepare a sample data set, means because whenever you train the model, you have to have a training data set. So you have to train the data. For that, you prepare a data set, then load the data set, and you train the model. Once the training is done, you deploy the model, and then you use that model. So you take a base model, train with a custom data. Once the training is completed, you will be deploying that model and then use that newly created model. So it's a customized model. Okay. So fine tuning is a time consuming process and a costly process. Then what is a solution? How we can customize with the custom data? For that, we use RAG. So RAG is retrieval augmented generation. What is retrieval augmented generation? Retrieval augmented generation means we have some data in some external database, like a vector database. And from the vector database, we will find the matching information and give that information to the model. So model is answering based on that given data. That means you remember that in the prompt engineering, we discussed about the grounding content, right? So here the grounding content or contextual data, which means based on this data only, the model is going to answer this. So now the question is how to get this data. So this data can be stored inside a database. From the database, we can take that information and give to the model as a grounding data. So the model can generate the answers based on that. But performance of the RAG application is based on the database's performance, the frameworks which you use for building this, and the search scenario. Okay, so this is the process. How? Whenever you ask a question, this question is going to the database. But before searching inside the database, it is converted into an embeddings data. That is, my question is converted into a numeric data, and that numeric data is searched inside the database. Where this is our vector database. When we search for the vector database, it returns some matching documents, some relevant informations. That relevant informations is passed as a context data. So our question is the instruction plus the context data. If you remember, whenever we make a request, we are sending our question plus this context data, right? So that is what here. So now the context data is coming from where? The vector database. And now the question and the context data goes to the Gen AI model. And Gen AI model is creating the answer based on that context data and returns back to the user. Okay, so this is the RAG architecture. So in RAG architecture, we have the data which is stored inside the database. When the user makes a query, the query first goes to the vector database and it is search for the matching information and it returns the matching information. Maybe one or more matching data will be there. The most matching documents will be returned and it will be combined with the question. So question plus context is passed to the Gen AI model and the model is generating the response. Okay, so now we have already discussed what is a vector database, what is vectorization, then what is the importance of context data in the prompt engineering, and then we also discussed what is RAG approach, because in RAG conceptually we are using the vector database. Now, how to use the Cosmos DB for NoSQL as a vector database in our RAG applications. So there are two types of vector databases available. One is integrated vector database and a pure vector database. What is the difference between them? And our NoSQL means Azure Cosmos DB for NoSQL comes in which category? Is it an integrated vector database or is it a pure vector database? So pure vector database is designed to efficiently store and manage the vector embeddings along with a small amount of metadata. It is separate from the data source which the embeddings are derived. So if you remember in this diagram, one of the previous diagram of vector databases, yes. So here we have discussed this is our data source, right? So this may be a database or this may be a file or this may be a website or anything. So from the data source, we are extracting the data, converting them into the embeddings model and store it here. Now the question, whether this database will store the text data plus the vector data or it will store only the vector data. That means for storing the text data, we need a separate database. Okay. So in pure vector databases, it stores only the vector data. Okay. The actual text data remains in other place. Means if it is in a different database or different file, it remains there. So this vector database will contains only the vector information. It does not store the text data, right? But in case of integrated, integrated vector database, okay, you can store index and the query embeddings alongside the corresponding original data. That means it will store the index. Index is required for enhancing the search operations. Then embeddings data and the corresponding original data. Everything is stored in a single database. Okay. This approach eliminates the extra cost of replicating data in a separate pure vector database because we are storing the original text data in one database plus the vector data is in a different database. That is not required, right? So if we can store them together, that's better. So integrated vector databases benefit. They store the vector data along with the original text data. So where the vector databases used? Vector databases are used in numerous domains and situations across analytical and generative AI, including natural language processing, video and image recognition, recommendation systems, search, and more. So wherever you have to go and find the matching informations, there you can use the vector data. Okay, like identify similar images, documents, and songs based on their contents, themes, sentiment, and styles, or identify similar products based on their characteristics, features, and user groups. Okay, recommend contents, products, and services based on individual preferences. Okay, so that means in Netflix and all, you can see whenever you complete watching a movie. Suppose today you have watched an action movie, then below it will suggest, okay, because you have watched action movie, we are suggesting some more movies, right? So that means the suggestion is coming from the type of movie that you have watched. Okay, so it goes to the database and find the matching informations or matching records uh, corresponding to the one which you have already used, right? So these are some of the use cases of the vector database. Now, what is the use of vector database in RAG? So in RAG architecture, I have showed you there is a vector database which stores the vector embeddings. Whenever the user makes a query, the query first go to the vector database, find the matching answers, and then send that matching answers to the model along with the query so that the model is able to generate the response. So what is the benefit of using vector database in RAG is we can generate contextually relevant and accurate responses to user prompt from AI models. So that contextual data is coming to the AI models from the databases. Overcome the LLM's token limits because it is not possible for us to pass the complete informations. I told you in the beginning, suppose in a company we have 100 employees working, providing all 100 employees data in the context is not possible. Okay, suppose if I'm searching for a particular employee, get only his information and put inside the context. So instead of including 100 employees information in the context, only one employee's information or two employees information putting in the context is better because every model has a token limit. You remember that in the beginning I told you that there is a 4K model, 16K model, 128K models are there, right? So if you are using a 16K model means it can store maximum 16,000 tokens, means 16,000 words. 16,000 word means 100 employees information. If I store, it may exceed that 16,000 limit. But instead of that, if I'm storing only, or if I'm passing only one employee's information as a context data, it will fit within the 16,000, right? So that's the second point, overcome the LLM's token limit. Third is reduce the cost from frequent fine tuning or updated data. I told you fine tuning is also a way to customize your model, but the problem is uh, fine tuning is very costly process. It requires uh, high performance compute like a GPU and CPU based computers are required. But and also one problem is if the data is continuously modifying, so every day we cannot do fine tuning, or every week we cannot do fine tuning, because fine tuning itself will take time. So if their data is frequently updating, then it's better to use which approach? RAG. Because in RAG, you are not modifying the model. You use a database which stores the dynamic data. Whenever you need the information, you connect to the database, read that information, and generate the answers based on that. That's it. The model does not get modified. Now, what is vector search? Vector search is a method that helps you to find similar items based on the data characteristics rather than by exact matchings on a property field. So usually in SQL, means relational databases, what you do is a equality search, right? Or some relational operator you use to search. For example, select star from employees where salary greater than 5,000, or select star from employees where name equal to Kumar. Means you are actually searching based on a particular field or column. But in generative AI applications, since we are dealing with the natural language text, we cannot expect the user will always give a correct statement every time. For example, if I have to expect or if I'm expecting the employee Kumar's data, so I can ask, can you provide the details about Kumar? So this is one way to ask the question. Same question I can ask in a different format. Okay. So I am looking for the informations of Kumar who works in Synergetics. This is another way of asking the same question. So look at the contextual meaning of this question. Meaning is same, but I'm asking the question in the two different format, two different ways, right? Then how you will do a equality search? Is it possible to go and search based on a column? No. So then what we have to do is we have to do a semantic search. Semantic search means what? What is the meaning of that statement? Then find the text which has similar meaning. Suppose I am asking, tell me about the experience of Kumar, who is working in Synergetics. Then what is the meaning is I am asking about the experience of Kumar. So go to the database and search for the experience of Kumar who is working in Synergetics. So that is a important statement. Search with that meaning. If any paragraph or any document which is matching that information, get that information. Okay. It works by taking the vector representations of your data that you created by using the machine learning model by using an embeddings API. So we have already seen the embeddings model is capable to convert your text into vector embeddings. And there are many other vector embeddings model available, it, not only in OpenAI. It then measures the distance between the data vectors and your query vector. So inside the database, we are storing the data in a multi-dimensional vector, right? So the distance between the actual data which is stored in the database and the query, if they are similar or they are near, which means your data is more close to your query, means it has more matching. Okay, so you remember the picture that plot the data inside a multi-dimensional vector. So all the athlete related data comes in one place, all the animal related information comes in one place. So if I'm searching for animal, so that my query data is more close to animals data. So it will go and find the more matching informations from the animal section. Or if I'm searching for, if I'm asking for athlete, then it will go and identify the matching documents which is more close to my query. The data vectors that are more closest to your query vector are the ones that are found to be more similar semantically. So which is more close or which is more matching with your query data will be returned as the vector search result. So if you have to do this in our Cosmos DB, in Cosmos DB, we need to have the indexing to be done. So in Cosmos DB, there are different indexing policies we have. Okay, so in Cosmos DB, I have already showed you the indexing policy. So every container that you create will have an indexing policy by default configured. Okay, so what is the use of index? Index is very much required whenever you search for the data, right? Because if you are searching for any data, it first look into the index to identify the position of the data, right? So that is a normal use of index. But to index the data in Cosmos DB, it uses an indexing policy because the indexing policy defines when to index and which of the columns to index. Okay. The default indexing policy for a newly created containers indexes every property of every item and enforces a range indexes for any string or number. So whenever you whenever you create a new container, it is automatically creating an range index, which is a string or number based index for every text column. Okay. The total consumed storage is the combination of both data size and the index size. So what is the total capacity or total storage consumption for your database is? It's the total size of your index and the total data size. The Azure Cosmos DB support two indexing mode. One is consistent and another one is none. If you are setting the indexing mode as consistent, the index is updated synchronously as you create, update, or delete the item. That means whenever a new item is inserted, automatically the index is updated. Whenever you update, automatically the index is updated. Whenever you delete an item, automatically the index is updated. That means for every operation that you perform inside the container, automatically the corresponding index operation is also executed. But for larger data processing, this is not a good approach because suppose if I have to insert 1,000 records, when I insert the first record, the index is created. When I create the second record, index is updated. When I insert the third record, index is updated. So that means for every operation, the index is getting updated. So that is time consuming process, right? So in case of bulk operations, it is better to use what? The indexing mode as none. So indexing is disabled on the container. This mode is commonly used when a container is used as a pure key value store without the need for secondary indexes. Means we can say we need to disable the indexing for that. So you can, if you want, you can enable this indexing later as well. Okay. Vector indexes. So there are different types of indexes supported by Cosmos DB, but one type of index is vector index. So what is a vector index? Since we are dealing with the vector data, we have to index our container using the vector indexes. Vector indexes increase the efficiency by performing vector searches by using the vector distance system functions. Remember this function because whenever we do a vector search, we are actually using which function? Vector distance function. So this will calculate the distance between the user query and the vector data which is stored inside the database. So in vector indexes will help us to increase the efficiency of the search operation. Vector searches, vector searches have lower latency, higher throughput, and less RU consumption when applying a vector index. So if you are using the Cosmos DB as a vector database, you have to enable vector index so that vector searches will be more faster and it provides low latency. Currently, vector policies and vector indexes are immutable after creation. That means once it is uh, created, means the vector policy and the vector index are created, you cannot modify that. Okay. To make changes, you have to create a new collection. Means if the collection is created and you have set the vector indexing policy, then you cannot change that. If you have to change, you have to copy the data to a new collection and set a new policy. If you want to use the vector feature in Azure Cosmos DB for NoSQL, you have to explicitly enable the vector feature because vector search feature is not enabled in Cosmos DB by default. If you want to enable that, you have to go to the features section and enable that explicitly. I have already enabled in my database. I can show you that from where you can enable it. So first you have to go to your database. This is your vector database. Go to the settings and the features. And here you can see vector search for NoSQL API. By default, it is off, but I have enabled it. If you click on this, you can see there is an option to enable this. Currently, it is enabled so that it's showing close button only. Otherwise, there will be a enable option. When you click on enable, it will change from off to on. Okay. Otherwise, you can do it through command as well. Okay. That means you can run this AZ Cosmos DB update command and enable this capability as enable NoSQL vector search. So this will take some time. Okay. So the registration request will be auto approved. That means when you enable the vector search, it will be automatically approved and it will automatically enable, but it takes at least 15 minutes to take effect. Okay, means that feature will be enabled after 15 seconds, 15 minutes only. Okay, so you have to wait for 15 minutes before you start storing the data. Indexing policies in Cosmos DB, when you configure, typically there is an default indexing policy that will automatically what index all the columns. Okay, but it is possible for us to customize that indexing policy. Okay, that means suppose we don't want to include some of the columns in the index, then that you can explicitly mention. So whenever you do vector indexing, it is better to use a custom index policy because vector columns I don't want to index or some additional columns we don't want to index. In such scenario, you can explicitly modify the indexing policy. Okay. So inside the indexing policy, it's a indexing policy is typically in a JSON format. So there is a include or exclude property section. You can specify that include and exclude. Inside the include and exclude section, you can specify which of the columns to be included in the index or which of the columns to be excluded from the indexing. And also you can set the indexing mode. Indexing mode, I said either consistent or the none. Right. So this is what I have already showed you. If you are using consistent, this is automatically updated. But if you set none, then after the bulk operation, you can enable this. By default, you can disable this indexing if you set it to none, which means if you are whenever you do the bulk operations, you can disable the indexing. After this bulk operation is completed, you can enable this index back to consistent mode. Including or excluding the property path. So typically, when you create the index policies, you can specify the columns which you need to include or exclude in the indexing. Okay, so what is the benefit is if you include only some selected or required columns in the indexing, it can reduce the latency and RU. Okay, because if it is start indexing all the columns, it will consumes more RU. RU means request unit. So the cost is calculated based on the RU. Okay. So if you start indexing on all the columns, so it will take more time and more cost. So better you can exclude some of the columns from the indexing. But how to specify that? You have to specify by specifying the path of the attributes. Suppose if it is a string or number value, you can specify slash and then name of that column. But if it is an array type, you can specify slash, then within the array, and you can specify the index. Okay, so you can say slash 0, 1, etc. Slash star if you specify, which means any columns which is coming under that property will not be indexed or will be indexed. So that depends on include or exclude. If you say exclude of slash star, which means all columns are excluded. Okay. Or if you say slash name, which means only name is indexed or name is not indexed. Okay, so based on the property path, it will include or exclude that. Vector indexes is increasing the efficiency when performing the vector searches using the vector distance function, and vector searches have lower latency, higher throughput, and less RU consumption when applying the vector index. So here there are some vector index types you can specify. If you say flat as the type, okay, the index type as flat, what is that? Store the vectors on the same index as other indexed properties. So where the other indexed properties are stored, your vectors vectors also will be stored inside the same index. Quantized flat, if you set as the type, it quantizes, that is, compresses vectors before storing on the index. So it compress the size of this vector and then store. Before storing in the index, it compress. This can improve latency and throughput at the cost of a small amount of accuracy. So cost is little bit higher, but you can say the latency and throughput is increased. Maximum dimension supported is 4096. Disk ANN. This creates an index based on the disk ANN or fast and efficient approximate search. So this is creating an index based on the disk ANN policy or algorithm. So it uses a different storage or different index for your vector data. Okay, so that is giving a faster search operation for your vector query. This is a sample vector indexing policy. So here you can see indexing mode is consistent, which means we have to uh, index the data whenever the insert or update or delete operation is performed. And automatic is true. And included path means we are including all these columns from our document. So path equal to slash star means all the columns are indexed except these. So here in the excluded path, we have given two columns like a slash underscore e tag slash question mark, which means under the e tag, any value is coming that is not indexed. That means the e tag values are not indexed. And also slash vector slash star means that vector column values also not indexed. Okay. And below vector index type you can specify. So vector index we are separately storing. So path equal to slash vector. So the vector data we are storing in a vector index and the type of vector index is disk ANN. Okay. So in this we have identified that while creating an Azure Cosmos DB for NoSQL, it is possible for us to enable vector search in Cosmos DB, and we can store the actual data and the vector data together because Azure Cosmos DB for NoSQL is an integrated vector storage. Okay, and it is possible to store or so it is possible to configure the custom indexing policies. Okay. Now we can see this in practical, how we can use NoSQL as a vector storage and how it is performing vector search. Let's see, I'm taking you to an example. So currently you can see in my account, I have one database and one collection, which I'm deleting now. Okay, I don't want this. See, I just deleted the existing database. This is a normal database and collection, which I don't want. Okay, fine. You can see now this account does not have any database. Now let's start this demo. So here I have a Python notebook, which is in which I am going to demonstrate the RAG approach, that is retrieval augmented generation by using the Cosmos DB for NoSQL. Means the Azure Cosmos DB for NoSQL is used as a vector storage, and I'm going to store some data inside the Cosmos DB, okay, as a vector data, and then using the RAG, I will do a vector search and generate the informations. So for that, the first thing is I have to create a Cosmos DB account with a serverless capacity. So recommended approach is use serverless. Since I already have a vector database or sorry, I already have a account created and you can see this is already serverless only. Can you see capacity mode is already serverless and it's a key and the endpoint. Here you can see this is the Cosmos DB's URI and this is the primary key for authentication. So the key and authentication I have to extract and store inside the env file. So here I have a sampled env file. So inside this, you can see I'm storing the key and endpoint. So this is my Cosmos underscore URI, which is the Cosmos DB endpoint, and Cosmos underscore key, which is the authentication key that I have already stored. Next is I need a open AI account because I have to use an embeddings model to create the embeddings, and I need a GPT model to generate the answers. So there are two models to be deployed. One is a embeddings model. Another one is a GPT model. So I already created an OpenAI account. So I can show that I have already showed. This is my OpenAI account. Okay, this OpenAI account is created. Inside this, I have deployed totally three models I deployed: GPT 3.5, GPT-4, and a text embeddings ADA002. So this is my embeddings model. This is my GPT model. So I'm going to use these two. So GPT-4 is not required. I'm not going to use that, but I'm going to use GPT 3.5 and the text embeddings. Okay. So I have already deployed these models. Okay. Then I need the authentication key and endpoint for the OpenAI as well. So here in the OpenAI, I can see the endpoint. This is the endpoint for the OpenAI, and this is the authentication key. That also I'm storing inside the environment file. You can see OpenAI endpoint. This is the endpoint. This is OpenAI key, and this is the authentication key. Then OpenAI type, some other additional parameters which is required. The OpenAI type is Azure because I'm using Azure OpenAI. The next is OpenAI version. This is the version number of the API. Then embeddings deployment name. So what is the name of the deployment? This is the name of the deployment. Okay. So this is the name of the deployment and this is the model name. Okay. So I have the deployment name and the model name are same. So I am using this. Similarly, the GPT model also. Can you see the completions deployment and completions model? I'm using GPT 3.5 Turbo 16K. The number of dimensions for the embeddings is 1536. Okay, that is a dimension support. Okay, this is not required. So these are the different environment variables I have stored in the env file. Now I have a sample data. This I'll delete. This is a sample data. This sample data contains some JSON information. As you can see, it is containing the ID, title, content, and category. So title is the name of the Azure service. Content is a description about the Azure service. Okay. Similar, you can see this is app service. This is Azure function, cognitive services, storage, SQL database, and so on. So there are a lot of Azure services information is here. Okay, so this is the complete Azure services information is added. So this is my original data. So I want to ask some questions about the Azure services. For example, if I have a chat agent, I'm going to ask, okay, tell me which Azure service I can use for deploying containers, or which of the container services are available in Azure. Or I'm asking which networking service I can use. Or I can ask which is the NoSQL data storage available for Azure. Okay, so this complete list of JSONs containing the answer for that. But there are, I think, 107 entries there. So providing that 107 informations as a context data is not possible. So what we are going to do first is we convert this data into vector embeddings and then store inside a Cosmos DB. Okay, that is what I'm going to do first. For that, first I have to install some libraries. This library I have already installed because I'm executing a Python notebook. I think this is already installed. Okay, this is done. Then install the required libraries. I'm using some Python libraries like NumPy, OpenAI, Python.env, Azure Core, and Azure Cosmos. So I execute this. So it's installing those required packages. All these are already installed. So fine. Then some of the imports I have to do. So I'm importing the JSON, datetime, time, URL lib, then Azure error, Azure credential, Cosmos client, so and so. So import them. It's fine. Okay. Now from the environment variable, so this is my environment variable file, that is the env file. So from the env file, I want to load these keys and other values into the variables. Okay, so I'm loading that. So you can see using the .env, I'm loading this values from this file and putting into the variables. So these are the different variables I have. Next, I'm creating a Azure Open AI client. So I'm creating an instance of Azure Open AI by passing the OpenAI key and endpoint and the version. Okay, fine. Now this is a function for creating the embeddings. So I am passing a text here. You can see here, this is a Python function. I can pass a text and this function is supposed to invoke the embeddings. Can you see? AOI client dot embeddings dot create, and we are passing the text and the name of the embeddings model. So using this embeddings model, it will generate the embeddings, that is numeric data, and returns that numeric data. So here response dot model dump means we'll get the embeddings. From there, we are returning this embeddings column value. So this is a function which I am creating to returns the embedding of the given text. Okay. Now I have my data, means input data inside the JSON file. This is my JSON file. So I have this data in my JSON file, which I'm reading and then storing into the variable called a data variable. Okay, so I have read the complete data into this data file and then reading that data into the data variable. So now complete data in the data variable. Okay, if you want to try printing this, just to print, so it will print the first record. So can you see this is the first record example? So it loaded successfully. After that, I am going to create embeddings for my title and the content. So here there are two columns I'm embedding. So title I'm embedding and also the content column I'm embedding. So the text column, sorry, the title column and the content column, both the columns I'm going to convert into number types. So you can see this data is the array of data which I have loaded, right? This is the data. And I'm using a loop to go through each one of this. Then I'm creating an item So I'm updating this item with its vector data. So this each item has an ID. Okay, ID I'm converting into a number type, sorry, a string type, because inside the Cosmos DB, ID field should be a string type. So I'm converting that ID as a string type, and then title I'm storing as it is, content I'm storing as it is, and the title embedding and content embeddings I'm going to generate using which function. So I have already created a function here, right? This is the function. So when I pass the text here, it returns the embeddings of that. Okay. So here I'm calling the generate embeddings of title and generate embeddings of content. So that I'm going to store inside the document itself. Okay. So inside the title vector, which is store the title vector data, content vector, which is store the content vector data. The actual text and actual content is also here. That's why it is called an integrated vector database. That means the actual original text is here, and it's a vector representation is here within the same document. So I will go and vectorize each and every document. There are 107 documents. So I'm going to vectorize one by one. So it takes some time. We have to wait. Okay, so here you can see all the documents are embedded, and it is stored inside this data variable itself. Okay, so now printing inside this will not be possible. So I'm going to write into a file so that we can see what is converted. So I'm writing this data into a another JSON file. Yes, it is done. Now to see that, we can open that. See, this is the JSON data which is created. So we can see it has the ID, title, and the content. So this is the original content, and this is the title vector. See, this is 1536 columns or vector data will be there. A very lengthy one. Okay. Also, you will see the title vector and the content vector. There are two vectors. See, this is the content vector. Okay. So every document will have two vectors. This is title vector, content vector. This will also have title vector and content vector. This will also have title vector and content vector. So this is what we are going to store inside the Cosmos DB. Okay. So we have the data ready in the data variable, and I'm going to connect to the Cosmos DB and store that data there. So this is for connecting to the Cosmos DB account using the Cosmos DB endpoint and the authentication key. Okay, it's connected. And we are planning to create a new database. The new database name is Vector NoSQL DB, or if you want a different name, you can give that. So this is going to create a database if it is not exist. Okay. Okay, it's created. Database is created. Now we are, let me show that. Yes, so you can see the database is created. Now we have to store the data inside this. But before storing the data, I am planning the vector indexing policy. So you can see this here, vector embeddings policy. In the vector embeddings, I have two vector columns. One is title vector and another one is content vector. So this is both are 1536 dimensions. Distant function is cosine. Data type is float 32. So this is the vector embeddings information. And I'm going to define a indexing policy. So let me execute. This is a vector embeddings policy. And this is the normal document embeddings policy. So in document embeddings, I am including all the fields, excluding these fields. So this column I don't want to include in index. This column I don't want to include in index. This column I don't want to include in index because these columns are already included in the vector embeddings. So here, vector indexes. Can you see slash title vector and what type of index is used? Quantized flat, which is a compressed one. Title vector is again quantized flat. So there are two vector embeddings columns. Both are storing in a compressed format. So I have created this indexing policy variable. Now we have to create a container with that indexing policy and vector embeddings policy. See, I am going to create a new container inside that with the container name, and ID is the partition key. So ID is going to be acting as the partition key. I'm defining the normal indexing policy as well as vector indexing policy. So look at that. Executing this, you can see container is created with this name. Fine. So let me get the container client. Okay, inside this, I got this. If you go back here and verify, see, it's created. And if you here you can see the indexing policy. Can you see? Vector indexing, everything is defined. Now we have to store the data there. So we have already the data in the data variable. So that data variable we are going to store inside the uh, collection. So I'm opening this file. This file we have written, right? So from this file, I'm reading the data and storing into this. So execute this. So it is inserting each document inside this Cosmos DB. You can see. Okay, done. All the 107 documents stored. Now, if I go to the items, you can see this is the first document, second document, third document, and so on. Right? So each document has a content vector and a title vector. Right? So we have successfully stored the data inside the Cosmos DB account. Now we can try a search. So for that, we have to create a search function, vector search function, where I will be passing the query here. Okay, what is my search query I'm passing? And maximum how many matching documents I have to return? Number of results equal to 5 means top 5 matching documents I have to return. So because this is a similarity search. So which of the documents are top matching? So top matching 5 documents I have to return. So 5 is the default value I'm setting. So first, you know that before we do the search, our query must be converted into number, right? So for that, I'm using the generate embeddings function to convert my query into the embeddings. So this is my query embedding, and I'm performing a search operation. Can you see query items? Select top these number of variables or this number of documents I have to get. So what is the this actually at the rate num results means is a parameter. The parameter value I'm passing as number of results. Number of results is 5. So here at the rate number of results means 5. So select top 5 c dot content means I have to return the content, title, category, and the similarity score. That means find the vector distance of content vector comma embedding. So embedding means our query embedding. So identify the distance between the content vector and the query vector. That is our question vector. So that is returns as which column? Similarity score from the collection order by vector distance of content vector and embedding means the top matching results will come first. That is in the ascending order of, sorry, descending order of what the distance vector. So, right. So that will be returned. So here, this is the function which for similarity search. So I have created the function and I'm going to test that function. See, this is what the query I'm going to try now. What are the services for running ML models? So in Azure, what are the different services available for ML models? I'm going to pass this query to my vector search function. Vector search is going to return the top matching 5 documents, and I'm printing the results here. When I execute this, see, this is the top matching one, 0.85. And this is the first result which is matching. This is the second result. This is the third results, and this is the fourth results, right? So you can see the content is different. This is the cloud-based one. This is a fully managed one, something, right? So the top 5 matching results are returned. Okay, so this is our context data. So now whenever I ask a question, this is the information coming from the database. Now we will give this information to the AI model to generate the answer. So my question is this, or I can try with a different question. So let me put a different question. So what are some NoSQL databases in Azure? So let's see. Azure Cosmos DB, Azure Table Storage, Azure SQL Database, Azure Database for MySQL. So these are supporting NoSQL functionality. Or these are all databases because I have asked about NoSQL databases, right? So it is supporting the database related. So Cosmos DB is the top matching result. The next matching result is this. So you can see it's a top match result is similarity score is lower when you go down, right? So now using this information, I have to create a chat agent. So here I'm creating a chat request. For that, I will be passing the search results, which is the context data and the query to this one. So in the system prompt, I'm clearly saying you are an intelligent assist for Microsoft Azure services. You are designed to provide helpful answers for user questions about the Azure services and so and so. So I'm giving all the instructions. If you don't know the answer, you say I don't know or I am not sure so and so. Okay. And then this is the system message. In the system message, I'm passing the system prompt. And inside the messages, I'm appending this one, messages dot append, and I'm passing this. This is a system message, and this is a item of content, and this is a user message which is created. The user query is added here. Then I'm making a chat request. This is the OpenAI client dot chat dot completions dot create. So I'm making a chat request by passing the model name and the messages and the temperature I'm setting 0. Remember, if you want a static type of answer, okay, I don't want more creative answers, so I need a static answer. So I'm setting the temperature value to 0. So when I make a request, I should get a response. So I'm creating this function. The function is ready. Now I can test this. So I will run this one. It will ask for the prompt. Okay, I can type my prompt and it will do a vector search here. When the vector search returns the search results, that search results we are passing along with the user query to the generate completion, which returns the completion result. Okay, that is this is the one which is calling the GPT model, and this search result is used as the context data, and this is our user query. So context data and user query is passed to the GPT model, and GPT model returns the result. Let's see. I'm going to run this. So at the top, you can see it is asking a question. So I'm asking. So here I'm asking um, which of the container services are available in Azure? Asking a question. So it will do a search. And here below you can see some matching answers. Azure offers several container services like AKS, ACI, ACR, and so on. So, okay. Now I can ask another question because I'm executing this in a loop, right? In a while loop. So I can ask a second question. Maybe what is Azure Service Bus? Next question I'm asking. So it generates an answer and give. I don't know whether that JSON contains information about service bus. So it is searching for that. It is taking time. There is no matching answer found. Let's stop and rerun. I don't know whether service bus information is what is Azure service bus. Okay. So the suggestions. Azure Service Bus is a fully managed enterprise-grade messaging service. See, what I'm asking, it is giving that corresponding answer. So now I can ask another question, say, hmm, what is Azure Open AI? Sorry, AI spelling is mistake. Okay, let's take. But okay, this is saying I'm sorry I couldn't find information about this. Let's search for tell me about Azure Cosmos DB. Let's see whether it will. Okay, yeah. Below you can see Azure Cosmos DB is a fully managed, globally distributed database, right? So that means whenever I ask a prompt, it will search inside the database, and the search result and my query is passed to the model so that the model returns the generated result. Okay, so this is the RAG approach, that is retrieval augmented generation. So the data which is stored inside this vector database is used as a context data. But database contains a very large sized text or large data, large amount of data. All data we cannot use as a context. So we perform a similarity search. So when you perform a similarity search, it will find the top matching results, 5 top matching results, and that is passed to the GPT model for generating the answer. So this is how we use uh, vector search, or this is how we use Azure Cosmos DB for NoSQL with vector search for our generative AI applications. So now that's the end of our session. And if you have any questions, any queries, please post your questions in the chat. So this is a customized notebook which you can check the Microsoft Learn website. In the Microsoft Learn website, you will see the sample code for Azure Cosmos DB for NoSQL and how to use this as a vector database for RAG applications. So you can uh, go to the Microsoft documentation website. How do we version control RAG embedding or add a new context as it comes? See, whenever the new data comes, you have to re-index, or whenever you insert, for creating new index, it doesn't matter. It will automatically index. But whenever the data changes, means you are in your application, you have to insert a new document. So it will automatically index because in Cosmos DB, it is automatically indexing whenever the new record comes, right? So you don't need to worry about what happens if new record comes, because it's not storing your data inside the model or anywhere. Every time when you make a request, it will connect to the database and search the data. Suppose today, if there are 100 records inside your document or inside your database, uh, it will, whenever I make a query, it will go and search in all the 100 documents. But after some minutes, you inserted five more records. So from 100, it will increase to 105. So whenever you insert a document, it automatically index, because our indexing policy is consistent, which will automatically index the data. It will automatically uh, uh, store that data. But the main important thing is you have to store the vector data also. Okay, not only the text data. You are inserting your text data along with the vector data. Okay, so that vectorization you have to do with the help of a background job or something like that. If you are not inserting the vector data manually. Okay, so if you are inserting only the text data, means the title and the content only, then using some Azure function, you can identify, okay, if there is a new record inserted, using the change feed, trigger a Azure function, and then modify the newly inserted document. Means create an embeddings and store inside that. Okay, so uh, I didn't see any other questions. So that's it from my side. Thank you, everyone. Okay, documenting embedding would be, they have to be rebuilt for whole and new context. No, no, only for the documents that you insert, you have to create new embeddings for that. It's not the entire uh, database. Suppose if you are inserting a new record using the Azure function, you have to update the new record with the embeddings data. That's it. Any other questions? Okay, so thank you, everyone. Have a good day.
Participants, you can leave this session now.